I'm Geoff. In this video, we're going to look at how I designed a corner clamp for clamping together picture frames and small boxes. This video is different to my normal videos because I'm working away from home and have fewer resources to put the video together. If you'd like to support the channel, you could buy me a coffee by clicking on the link in the description below. Now let's have a look at how I've designed the corner clamp. I'm using FreeCAD version 0.19, which was built on the 4th of September 2020, and I'm using the macOS platform. This is the corner clamp we're going to model today. First, we're going to model the base. So we'll start off with a new model, and I think we'll just get that saved as quickly as we can. Corner clamp, create a new directory called models. Save this one as the base, and we're going to switch to the part design workbench, and we'll create a body, and we'll create a sketch. We'll do it in the XY plane or top view. And the base will be a square with one corner cut off, so the easiest way to define that would be to use a polyline. These two long sides are equal, so we select them both and press the E key to make them the same length. Short sides are the same length as well, so we do the same thing again. And we'll make the whole thing symmetric about the origin, so we pick the top, left, bottom, right and the origin points and press the S key. We'll make the long sides 150 millimeters, and so I'm going to use the vertical distance constraint to do that. So press Shift V, make them 150. We'll zoom out a bit because obviously it's bigger than I thought. Then we will make the short sides 100 millimeters, and we'll do that with a horizontal distance constraint. So press Shift H, make that 100. That's now a fully constrained sketch, so we can close that. And we'll zoom to fit. And now that we've got that sketch, we will pad it out using the pad tool. And we will make it 19 millimeters thick. One thing I discovered in another design is that the topological naming problem also affects the assembly process. It should have been obvious at the time to me, but it wasn't, and it was only after I thought about it for a little while that it became apparent that that was what was happening. And I'll do a video shortly showing exactly what I was seeing and the effects of it. In order to counter that in this design, what we're going to do is we're going to place the drill holes that we need to mount the various parts on top of the base into the design before we start trying to assemble anything. The drill holes, the screws are going to come through the bottom, so what we'll do is we'll switch to bottom view, and then we will create a datum plane on the bottom face, disconnect the plane from the face, and then we will create a sketch on that plane. Now what's going to happen is there will be drill holes along this side here and this side here, and they will mount the fences, and then we drill holes across here which will mount the thrust plate. So for the drill holes that mount the fences, which are here and here, what we're going to do is we're going to create two drill holes on this side and then mirror it around a 45-degree line here so that they appear on this side as well. So in order to do that, what I'm going to do is create two construction lines. First for the drill holes themselves, and the second as the mirror line, which we will mirror the drill holes around. The mirror line will be at 45 degrees so that it will mirror the holes correctly. The holes will just be placed at the end of this construction line, so we'll switch back to regular geometry and place 2 holes. The distance between the holes will be 80 millimeters, so we will set that using a horizontal distance constraint by selecting the line and pressing Shift H, and we'll make it 80 millimeters. The outer hole will be 10 millimeters from the edge. Again, we will set that using a horizontal distance constraint, pressing Shift H, and it's going to be 65 millimeters. And it's also going to be 10 millimeters from this edge, so we set that using a vertical distance constraint, which is done by using Shift V, and it too will be 65 millimeters. And now we have 3 degrees of freedom. One is going to be the length of this line, and it really doesn't matter how long that is because it is just a reference line that we will use for the mirror. The other 2 are the radius of the circles, and I'm going to use the hole tool to drill the holes, and so we don't need to worry about setting a radius, the diameter for the holes. The hole tool will do that when we use it. Now I'm going to disable the datum plane because I don't need it anymore. Then select the sketch and open the hole tool. Make that a little bit bigger so we can explain it. Okay, so using the hole tool, I'm going to set the profile to be isometric coarse. I'm going to set the size to be M2.5. It's going to be a 4G screw. The depth is going to be through all, so I'm going to push it the whole way through the base. And the type here is going to be a countersink, so that the screw heads are below the surface. Click OK, and now you can see we've got the 2 holes with the countersink in place. So we'll just fit that back again. And now what we're going to do is we will mirror these 2 holes across to the other side. So first of all we select the holes, and then we select the mirror tool. We change the plane to be construction line 2, and you see the holes are now in place along both sides. And we're going to go back to the back of the base and put in the holes for the thrust plate. So we'll create another datum plane, and we will create a sketch on that datum plane. And what we will do is we will create a 45-degree construction line here, and then put the holes at either end, just like we did down the bottom here. So the first thing I'm going to do is switch to construction mode and place a construction line, and we'll just draw it from one axis to the other. We will make the angle 45. We will switch back to regular geometry and place the circles for the holes. And we will set the distance of the holes using a length or distance constraint, and we will make them 75 millimeters apart. And you can see we have 2 degrees of freedom, which again will be the radii diameter of the circle, so we can ignore those. Turn off the datum plane because we don't need it anymore. come back to the sketch and then use the hole tool, and those holes will be exactly the same. So the profile is isometric coarse, it's going to be M2.5, it's going to be 4G, and it will have a countersink. And that, save that, that completes the base. Now we're going to model a fence. So we'll create a new model, and we'll save that, and we will just call it fence. We'll stay in the part design workbench. We'll create a new body and a new sketch. Again, we will do it on the XY plane. And the fence is just going to be a rectangle that will be symmetric around the origin point. So we will simply place the rectangle. We'll make it symmetric by picking the top left and bottom right corners and the origin and pressing the S key to make them symmetric. The width of the fence will be 20 millimeters, and we will use a vertical distance constraint to set that. So pressing Shift V will allow us to set the constraint. The length of the fence will be 100 millimeters, and we set that using a horizontal distance constraint by pressing Shift H. And the sketch is now fully constrained, so we can close it. And using the pad tool, we will pad that out to be 25 millimeters. Fit that and save that. And as with the base, we're now going to put some drill holes in the bottom. So we'll go into a bottom view. We'll create a datum plane on the bottom face. Detach the face from the datum plane. Then create a sketch on the plane. And the drill holes are just going to be centered on the horizontal axis. So we'll just create 2 circles. They're going to be symmetric around the origin. So we'll just pick the 2 center points of the circles and the origin point and press the S key to make them symmetric. And they are going to be 80 millimeters apart. So we will select the centers of the circles and use the horizontal distance constraint to set the distance. So press Shift H. And as you can see, it's still got 2 degrees of freedom, but that is the diameter of the circle, so we can ignore that. We'll turn off the datum plane. Select the sketch, and then we will use the hole tool to drill some holes. These holes are going to be 4G holes, just like the other holes, but they're not going to have countersink on them. In practice though, if I was building this out of MDF, I would countersink both sides of the hole in the base and the hole in the fence, because what MDF tends to do when you put a screw in it is pull some of the fibers down, and sometimes you will find that you cannot get the 2 pieces to mate securely. So we'll use the hole tool, and we'll set the profile to be isometric coarse, set the size to be 2.5, leave the class as 4G, and we will set the depth to be just 10 mil. As you can see, we now have the holes in the base. And now what we're going to do is we're going to start assembling it. So we will create a new model. We'll switch to the A2 Plus workbench, and we will save the model as assembly. and then we will import the base, and we will import 2 fences. Save that. Now what we're going to do is constrain the drill holes in the bottom of the fence to the drill holes in the top of the base. To do that, what we're going to do is we'll zoom in and we will select the top of the drill hole in the base, and then we will find the corresponding bottom of the drill hole in the fence, and we will use the circular edge constraint to bring it together. Accept that, switch back to isometric view, fit it, and you should see that it's in place. You can see now that the fence is in place, but it's only fixed at one point, and so it could rotate, meaning it's not a fully constrained sketch. So what we'll do is, for completeness, we will constrain the second drill hole in the fence to the hole in the base. But before I can do that, I just need to move the fence slightly so that I can then put the constraint in place. So we'll select the fence, and then we'll use the move selected part. And this will allow us to gain access to that other drill hole. I'm also going to switch into wireframe view, which means that I can now see the drill hole in both the base and the fence. So I'll select the drill hole in the base and the drill hole in the fence and use the circular edge constraint, which now brings that into place. I zoom to fit, it is now constrained in 2 places and cannot rotate. Now I'm going to do the same thing for the other fence. So we'll select circle here, representing the hole on the base, and this drill hole in the fence, put a circular edge constraint in place, and then as you can see it's pointing in the wrong direction, but by applying the circular edge constraint to the other part of the drill hole in the fence, we will pull the fence into position, as you can see, and we will save that. Now we're going to model the thrust plate. So we'll create a new model, switch back to the part design workbench. We will create a body and a sketch in the XY plane, and again it's just going to be a simple rectangle with 2 holes in it. It's going to be symmetric around the origin, so we pick the top left and bottom right corners and the origin point and press the S key to make it symmetric. It will be 25mm thick, and we'll set that using a vertical distance constraint by pressing Shift V, and we'll set its length to be 95mm, which is 10mm either side of the 2 mounting holes. So select the horizontal line and set a horizontal distance constraint by pressing Shift H and make it 95. We will close that because it's fully constrained, and we'll use the pad tool and make it 30 millimeters high. We'll save that and we will call it thrust plate. We now need to put the mounting holes in the bottom. So we will switch to a bottom view. We will create a datum plane on the bottom view and disconnect it from the bottom face. We'll then create a sketch on that datum plane. And again, we will just simply put 2 circles representing drill holes. The drill holes will be symmetric around the origin, so we select the center points of the holes and the origin point and use a symmetry constraint by pressing the S key. And the holes are also 75 mils apart, so we'll select their centers and set a horizontal distance constraint of 75 millimeters to put them into position. The 2 degrees of freedom again are the diameters of the circles, so we don't need to worry about those. We will turn off the datum plane. We will select the sketch and then use the hole tool, and we will set the profile to be isometric coarse, its size to be M2.5 and the depth to be 10. Now the next thing we need to do is place a counterbore drill hole for a T-nut, and that will be on the center of the front face. So we'll select the front face, we'll create a datum plane, we'll disconnect it from the face, and then we will create a sketch on the datum plane. Now, as before, we will just simply place a circle representing the drill hole. It will be on the vertical axis, and we know the height of the thrust plate is 30 millimeters, so we'll just put it straight in the middle of that by using a vertical distance constraint of 15. So we select the origin point and the center of the circle and press Shift V and set it to 15, close that, save that, and we'll turn off the datum plane and select the sketch again, then go back to the hole tool, and from here what we're going to do is we'll set the where is it? We will set the diameter to be 8 millimeters because the threaded insert thread pocket is about 8 millimeters. It's a little bit less than 8 millimeters, so we'll just make it that little bit bigger. We will make a counterbore, and the plate for the T-nut that I use is 20 millimeters, and its depth is 2 millimeters. Okay, and we will save that. And we'll switch back to the assembly, and we will import that part. So switch to the A2 Plus workbench. We will import the thrust plate. The hole for the T-nut faces the front, so when we constrain it we will have to rotate it, but we've already done that once already, so you know how to do that. So we will select this circle in the base, and then this circle in the thrust plate and use a circular edge constraint. And then we will select this circle in the base and this circle in the thrust plate and do the same thing. Set a circular edge constraint, and when we fit that, the thrust plate is facing in the correct direction. Now we're going to model the corner clamp head. And the purpose of the corner clamp is to push the material that's being glued together against the fences, and it has a threaded rod that passes through the thrust plate, which can be screwed forward and back to apply pressure as needed. So we're going to create a new model. I'm going to switch back to the part design workbench. We're going to create a new body and a new sketch, again in the XY plane. And because of its shape, we will again use a polyline for the design. And it has a shape that is very similar to a piece of military equipment, a flying wing, or B-2 bomber I think it's called. These two edges are perpendicular, so are these, so are these, so are these, and so are these. Oops. So are these. We will constrain, we will make this short vertical piece here coincident with the origin point, and we'll make the corners symmetric around the origin. We have 5 degrees of freedom, which we can easily set. So this face, these two sides are equal, so we set that using an equality constraint by pressing the E key. These two are also equal, so select and press the E key, and these two are as well. We're now down to 3 degrees of freedom, so we just need to set these pieces here. So this vertical piece here will be 30 millimeters, and we'll set that using a vertical distance constraint by pressing Shift B. This end piece here will be 20 millimeters, and we'll set that using a distance constraint of 20. And this length here we'll again set with a distance constraint, and it will be 75 mil. So it gives us a fairly substantial corner clamp. Now we will extrude that into a solid using the pad tool, and we'll make it 25 millimeters high. Save that there, and we'll call it the corner clamp. Fit that, save it. Oops. Save it there. Thinking about the design of this clamp and the nature of what we're trying to achieve with it, it seems to me that there is a chance that when we're gluing up
two pieces of wood at a right angle, there is a chance that we will get glue on this face and this face here. And that would mean that the clamp itself would stick to the workpiece, and we don't want that. So I think what we'll do is we'll make a change and we'll cut this corner off and go from there. So what we'll do is we'll go back to the original sketch. What we'll do is we will draw a line from here through to here. We will remove this constraint. We will clip off the pieces that we don't need. There. I don't know what I do. There. Okay, before we do that, I will remove this constraint here. Leave that. Now we'll try clipping off those pieces again. There we go, that's what we want. We'll set a vertical distance constraint on this front edge by pressing Shift V, and we'll make it 20 millimeters. And we will set a distance constraint along this edge of 65 millimeters. And now we have 2 degrees of freedom. Why are they different? They're not joined there. Okay. So we will make these two coincident as well. That one and that one, make them coincident. Zoom out. Probably got another problem there somewhere. Where is the 1 degree of freedom? That's set. That's right, that's rotating. That's why there's 1 degree of freedom. So what we'll do is we'll just make these points, or this line, symmetric around the origin line by using a symmetry constraint. You can now close that, and that takes care of that. Now the last thing that needs to be done on here is we need to create a counterboard pocket in here for a nut and a washer. The nut is going to be epoxied onto the threaded rod, and the washer is going to be used to hold it in place. So what we'll do is we will create a datum plane on this face here, and then we'll create a sketch on the datum plane, and again we will just place a circle and then use the hole tool to do the counterboard hole. The circle is in the middle of this, and we know that is 25 mil, so we'll set that using a distance constraint of 12.5 mil. We'll close the sketch and turn off the datum plane because we don't need it. Select the sketch and go back into the hole tool. And we will set the depth to be 12 millimeters. We'll set its diameter to be 12 millimeters. Then we'll do a counterbore of 16 millimeters. That is 2 millimeters deep. Save that, and we'll now put that into the assembly. What we're going to do is we're going to drop it into here. And we'll constrain it so that the bottom is coincident with this face and the two sides are coincident with the fences. So I'll switch back to the A2 Plus workbench and we will import the corner clamp. We will select the top face of the base and the bottom face of the clamp, and we will make them plane coincident, which puts them on the same plane. We will select face of one of the fences and the corresponding face on the corner clamp and make them plane coincident again. Accept that. As you can see at the moment, obviously there's a conflict here, but that will be resolved shortly. We select this face on the fence and this face on the clamp and choose the plane coincident constraint, which brings it into the proper position. Now the whole idea of this clamp here is that a threaded rod runs through here like so, and it is used to pull the clamp backwards and forwards. So if I select the clamp, I will show you what I mean by using the Move Selected Part tool. And basically the clamp will do this, move backwards and forwards like so, as controlled by the threaded rod. Now I'm going to leave the rest for you to continue with as an exercise. The idea would be to design a nut to go in here and a washer to go over the top, threaded rod through a T-nut there.
Well, I hope you found that interesting. If you did, click the like button below and subscribe to the channel. Please leave comments or topic suggestions below. And if you'd like to support the channel, please consider buying me a coffee by clicking on the link in the description below. Thank you for watching, and we'll see you next time.